Great seeing you here again. My name is Luc de Kuster, founder of the Kuster Academy, and welcome to my YouTube channel. In this video I'm going to make a new presentation, a new example about the net present value, how to calculate the net present value, and in this case we're going to consider two consecutive cash flows. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Let me start with reminding you about the formula on how to calculate the net present value. And the net present value is equal to the sum of the discounted cash flows starting period 1 to period n. When we have n periods, we have the cash flows index I represent the period I'm looking at, and I divide by the discount rate to the power I, and then we subtract the initial investment. We did that in the previous exercise. We only looked at one period, so we had I from 1 to 1, which was a very simple exercise. Now we're going to look at this for two periods, and we have an initial investment which is €55,000. That's the first element. We have a cash flow in period 1 which is equal to €35,500, and a cash flow in period 2 which is equal to €32,500. And we have a discount rate which is equal to 5.5%. So that's what we want to calculate, and that's what we're going to do in different steps. And at the end of this video I will recapitulate all the different calculations we did. The first thing we are going to do here is calculate the discount factor. We look at a discount rate equal to 5.5%. For year 1, we know that when we calculate the compound interest formula, we have 1 plus 0.055 to the power 1. And this gives us a very simple result. It's 1.055 or 105.5%. The discount factor what we have. So the discount factor is 1 divided by 1.055, which is approximately equal to 0.9479. And why do I mention here approximately? Well, there are more decimals that we can find here. And I just stop at 4 decimals. When you would do a calculation and you would use Excel, for example, you can find up to 20 decimals. But every time when we limit the number of decimals, we also may have some small differences in the calculation. It doesn't matter, it's not a problem, but you have to think about it that you may have some slight differences between the results. The second thing we do for year 2, now we have 1 plus 0.055 to the second power, and when I calculate the discount factor, I find here the result, or 0.8985. And we see that this factor is decreasing the further we go into the future. So that's the first element that we did. We calculated the different discount factors. What we have to do now is to calculate the discounted cash flows. Let's start with year 1 to calculate the discounted cash flows. So for year 1, we have the cash flow 1, which is 35,500. The discount factor is approximately equal to 0.9497, and we find the discounted cash flow for year 1 is 35,500 multiplied with 0.9497, which is again approximately equal to 33,649.29. We could say here easily 33,649 or 33,600. It doesn't really matter because we are looking at large numbers, and these last numbers don't always have a big effect on the final result. But we keep it like here. The second thing to do is for year 2. We know that the cash flow for year 2 is equal to 32,500. We know that the discount factor is approximately equal to 0.8985. And when we find the result, so the discount cash flow for year 2, we multiply 32,500 with 0.8985, which gives us 29,199.70, or we can say 29,200. The difference will be very small. What we now have to do is to calculate the total number of discounted cash flows and subtract the initial investment to find the final result. So for year 1, what we have for year 1, discounted cash flow 1 is equal to 33,649.29. For year 2, the discounted cash flow for 2 is 29,199.70. So we find, when we add all of those together, we find the sum of the discounted cash flows from 1 to 2 is equal to 848.99, or we could say 849. So these are the discounted cash flows. What we have to do now, we have to subtract the initial investment, so it's minus 55,000, and we find the net present value is in our case equal to 7,848.99, and we can say easily that this is 7.8k euro. Typically we use this when we are looking at the different calculations net present value wise. So this is more than sufficient because the other decimals don't change a lot. So that's the first part. Now we are going to have a look at the recapitulation. We're looking at the different elements and the different steps that we did in this exercise. Now we are going to recapitulate the exercise and review the different steps. First, you see the information about the discount rate. We have a discount rate set at 5.5%. The next thing we have, the information, is about the cash flows. For year 0, we have an initial investment of 55,000 euro. That's why we have the minus there, because when we do the calculations, this is a cost and is a negative value. For year 1, we have a cash flow of 35,500 euro, and for year 2, 32,500. When we look at the calculations, when we look at the rate factor, for the first year we have 1 plus 5.5% to the power 1, which gives us 105.5%. For the second year we have the same initial formula, 1 plus 5.5% to the second power, which gives us 111.3%. So we already see the effect here of compounding. Based on this, we can calculate the discount factors. The first year, we have a discount factor of 1 divided by 105.5%, which gives us 0.9479. For the second year, we do the same. We take 1 divided by 111.30%, and we find the discount factor of 0.8985. In order to calculate the discounted cash flows, we multiply them with the discount factor. So for year 1, we have the discounted cash flow 1, which is the multiplication of 35,500 with the discount factor, which is 0.9479, which gives us approximately 33,649.29 euro. For the second year, we do the same thing, and we find the discount factor for year 2, which is 29,199.70. Like I said, we may change this a little bit. We can say it's 33,649 and 29,200. It would give us approximately the same result. So we add the two discount factors in this case, which gives us 33,649.29 plus 29,199.70, which gives us 48.99, or we can say here 62,849. We subtract the initial investment, the 55,000, and we find a net present value of 7,848.99, which we typically in business would write as 7.8K. Be careful, it's not 7.9K. We have to look at the numbers. So we have 784, which means that we round to 8. When we look at 3 decimals, we would have 7.85. All depends a little bit on how we do the rounding. That was it for this second exercise. It's a little bit more complex, but you see how the calculation of the net present value works. That's it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.